So in a previous video, we looked at working with the calculator to solve some of these average value problems. And one of the problems that we solved was this one right here. But let's look to solve this without a calculator. What is the average value of this function on this interval? Okay, well, in order to find the average value on the interval, I know I'm going to need 1 over b minus a, the integral from a to b of my function. This is x squared, square root of x cubed plus 1 dx. Now, to solve this, we're going to need to do a u substitution, right? So I could come over here and say, I'm going to let u be x cubed plus 1. Then the derivative is going to be 3x squared dx. Right? But I don't have a 3x squared dx. What I have is an x squared, and so x squared is simply 1/3 du. Additionally, I have to be aware that if I'm going to be using u as my variable, then I need to substitute my limits of integration to be in terms of u. Well, if x is 0, u is equal to 1. And if x is equal to 2, I can't write this very neatly, my apologies. Right? If x is equal to 2 to the third power plus 9 or plus 1 is 9, so 8 plus 1. So that means that I can rewrite this as 1/2 times 1/3, because 1/3 du, the integral from 1 to 9 of u to the 1/2 du. Right? If I evaluate this, that's going to be 1/2 times 1/3, right? And then antiderivative of u to the 1/2 is 2/3 u to the 3/2. And I'm going to be evaluating that from 1 to 9. The 2/3 is in common, so I can go ahead and have 1/2 times 1/3 times 2/3. Well, that's just going to be 1/9. And I'm going to have 1/9 times, right? U to the 3/2 is the same thing as the square root of 9 to the third power minus the square root of 1 to the third power. Okay. If I consider what I have there, that's going to be 1/9. And of course, free response, I could leave it in that form, this first one. But I can go ahead and simplify this, and I'm going to have 9 to the third power square root is going to be 9 square roots of 9, then minus 1. And 9 square roots of 9 is 9 times 3, which is 27. So really I can say that this is the same thing as 27 minus 1 all over 9, or in other words, a simplified answer of 26 over 9. Okay. But depending on your course and your purposes, all the right numbers in all the right places might be good enough. Okay, let's look at another. What is the average value of the part of the curve y equals 3x minus x squared, which is in the first quadrant? So I need to be aware of what part of this curve is in the first quadrant. So let's think about what that curve looks like. So it's quadratic, and for this quadratic, it's going to be equal to 0 at 0, but also equal to 0 at 3. All right. And it's minus x squared, so it's actually going to open downwards. And that should make sense, given that we were told the value in the first quadrant. So let's make that look a little bit better. Look kind of like a starfish there. All right. So we have, well, I want to find out the average value of this function right there. Okay. So in that first quadrant. So now what am I going to do? Well, 1 over b minus a, the integral from a to b of the function, is going to give me the average value of the function. All right. So antiderivative of 3x minus x squared is going to be 3x squared over 2 minus x cubed over 3, all evaluated from 0 to 3. So that's going to give me 1/3 times 3 times 3 squared, that's going to be 27 over 2. 3 cubed, that's going to be minus 27 over 3. And it's going to then be minus 0, right, if I substitute in the 0. And that's a good enough answer for most of our purposes. But if not, look, I can go through and distribute my 1/3. And so I could say that that's 9/2 minus 9/3. And 9/2 minus 9/3 would be the same as 4.5 minus 3. And so I could say, oh, my answer is 1.5. All right. Mathematical fluidity with numbers can help make mathematics a little bit smoother. All right. So let's look at a few more. Here we have a closed interval. All right. Let's make this just a touch smaller, maybe. There we go. Now we can see. Closed interval. Which of the following could be a graph of the function with this property? Well, what is this telling us? This information is telling us that the average value is equal to 1, right? That average value is equal to 1. But it's also telling us the following. It's also telling us that the area under f of t dt is equal to 2. Why? Because what's 1/2 times 2? 1/2 times 2 is equal to 1. So let's consider, right? Let's consider from 2 to 4, right? Let's look at this one, right? I'm just going to kind of draw a box around this and say, hey, if I had a box, is the area of underneath this curve going to be equal to 2? Because technically that's what we have here. And it doesn't seem to be, right? Because if I drew this box would have an area of 4, and 2 would be half of this box, and that seems to be too much. Over here for this one, right, this one area should be a little bit easier to compute because that area right there is 2. And then this area up here would be base of 2, height of 2, it looks like. And this would also have an area of 2. And half of that area, right, because integral from 2 to 4 also represents the area underneath that curve. And 1 over 4 minus 2 is 1/2. So 1/2 times this area is 1. Well, clearly that's not going to be the case, right? That for this one, right, 1 over 4 minus 2, the integral from 2 to 4 of f of t dt for this one would be equal to 2, right? That half of the area would be 2. Then let's consider our next ones, right? Let's say over here, well, this one seems like I can kind of draw a box on here as well and say, hey, the area of that box is 2 by 2, which is 4, and then this area seems to be less than half. And then let's come and look at this one. If I come over here from 2 to 4, well, this has an area of 1, that has an area of 1, and 1/2 times 2 is equal to 1. So that one is a function, right? I could say that's an absolute value function almost, that absolute value function has an average value of 1, right? So interestingly, that means that 1 over 4 minus 2, the integral from 2 to 4 of the absolute value of x minus 3 dx is equal to 1, right? Because I could think of this as representing, right? And this wouldn't be x minus 3 actually, because I would have a height of 2, so it would be 2 times x minus 3. And that would set me up correctly. So if x was equal to 2, then the height would be 2. And if x was equal to 4, the height would be 2. So I could come up with a function that covers that. Pretty interesting. At least it is to me. Okay. And let's look at another one. Thank you for your patience here. So height of an object, what is the average height? So let's go ahead. We'll have on the interval from 0 to 2. So 1 over 2 minus 0, integral from 0 to 2, because average height, given height, of h of t dt. All right, and I'm not going to rewrite h of t because I don't need to. I can look at it here. So that's going to be 1/2 integral of 16 is 16t plus 7. Now here I have integral of the cosine, and my coefficient, my linear coefficient is pi over 4. So that means I need to multiply by 4 over pi. Sine is the inverse of the cosine, and then I'm still going to have pi over 4 times t. And that's being evaluated from 0 to 2. Okay. So if I go ahead and look at this evaluation, that's going to be 1/2. Right? If I substitute in 2, 16 times 2 is 32 plus 28 over pi times the sine of pi over 2. And I'm going to have all of that minus, substitute in 0, that's 0, plus 28 over pi times the sine of 0. Well, for each of these, 0 and sine of 0, all of that is going towards 0. The sine of pi over 2, that's just 1. So my solution then is going to be 1/2 of 32, and 1/2 of 32 is 16, and half of 28 over pi, so plus 14 over pi. Maybe it's a multiple choice question and your answer is given as 16 pi plus 14 all over pi. Not sure, multiple choice, but you have those options and those approaches. So a little bit harder, a little bit more thinking on these problems. And let's go ahead and look at one final one. So here's a key idea for this also. We want the average rate of change of y with respect to x on the closed interval. So that means I want the average value of change of y with respect to x. So average value of dy dx. This is not asking me for the average rate of change of dy dx. It's asking me for the average value of dy dx. So we have to be careful there. Now also notice that our interval is an interval where our function is continuous, because we know that's the reciprocal function, 1 over x, right? And so we're trying to say, hey, what's going to be the average value on our little interval here? So average value, 1 over b minus a, integral from a to b of f of x dx, where in this case f of x is dy dx. And that's going to give us 1/3 times the natural log of the absolute value of x. And I'm going to be evaluating that from 1 to 4, which will be 1/3 times the natural log of x minus the, or not natural log of x, excuse me, natural log of 4 minus the natural log of 1. And the natural log of 1 is 0, so that's going to be simply 1/3 natural log of 4. And maybe that's a satisfactory answer, but maybe you see the answer in another form. So I could say that that is the same as 2/3. Let's write this a little bit more neatly. 2/3 natural log of 2, and that's because the natural log of 4 is equal to the natural log of 2 squared, which is the same thing as 2 natural log of 2. But I could also write this as the natural log of the cubed root of 4, right? Because 1/3 natural log of 4, I could take that 1/3 power and bring it to the 4. So different ways you could provide the answers. A little bit more advanced for this one, a little bit longer video. If you have troubles with this, that's all right. If you can go back and look over the initial videos and understand the things at the introductory level, you should be okay. Thank you for your time.